Normally, black holes form from the collapse of massive stars, creating objects only a few times the mass of the Sun. The difference between regular black holes and supermassive ones. Real education, no complex math. When we think about supermassive black holes, it's easy to imagine something distant and abstract, but these giants really define the heart of galaxies. With masses ranging from millions to billions of times that of the Sun, they act like cosmic anchors, holding everything around them in orbit. By observing accretion disks that shine in X-rays and radio waves, astronomers are able to see the material dancing around these monsters, giving us a practical lesson in cosmic phenomena. It's amazing how complex concepts of astronomy explained can become visible, even without complicated formulas. And it's even more impressive to realize that these creatures shape the very evolution of the galaxies they reside in. The most incredible part is that, despite their size, supermassive black holes aren't easy to spot with the naked eye. Their effect is subtle but powerful. Imagine a colossal whirlpool pulling in matter and energy. That's how they leave their mark on the universe. This energy release creates amazing space storytelling, with mind-blowing science happening right before our telescopes. And when we talk about recent space discoveries, every observation adds a new layer to our understanding of the universe explained. Anyone watching space education videos can better understand how even invisible objects can teach us valuable lessons. Furthermore, locating these giants at the centers of galaxies shows us how deep space exploration isn't just adventure, it's a way to map the inner workings of the cosmos. Every accretion disk is a window into phenomena that challenge our intuition, offering practical examples of cosmic mysteries that you can contemplate, even from Earth. And while we watch these monsters, we begin to question, if we know so much, why is there still so much that remains unexpected in the universe? Some of these supermassive black holes, like TON 618, grew extremely massive within a few 100 million years after the Big Bang, much faster than current models predict. But the thing is, supermassive black holes are not just fascinating because of their size. Some of them, like TON 618, grew to incredible sizes in a fraction of the time we expected. It's like watching a tree grow in mere minutes, something that completely defies our expectations about how the universe should evolve. These extreme cases are essential for anyone looking for quality space education videos, as they show that mind-blowing science is not just theory, but real observation. Every detail we learn from TON 618 adds pieces to the puzzle of galaxy formation, opening up doors for new hypotheses about cosmic phenomena. And as we study these extremes, we start to wonder if we even understand the true limits of black hole growth. Additionally, studying these phenomena allows us to make fascinating real-world analogies. For instance, black holes might be compared to a cannon firing particles at light speed, sweeping clean paths for new stars to form in safe regions. Every insight from space discoveries reminds us that the cosmos is a natural laboratory of mind-blowing science. And while we marvel at these events, the question lingers, if these effects are so powerful, what about the extreme cases we have yet to observe? If confirmed, these observations suggest that our understanding of early galaxy formation and black hole growth is incomplete. TON 618 is a true cosmic colossus that challenges our imagination. Its mass reaches an astounding 66 billion times that of the Sun, located over 18 billion light-years away. It provides us with a direct glimpse into the young universe, allowing us to study cosmic mysteries that would otherwise remain hidden. Observing such a distant object in deep space exploration is like having a time machine, showing us the first chapters of the cosmic story. Every measurement and image of these quasars provides space discoveries that reveal the universe is more dynamic and unpredictable than we ever thought. And it's fascinating to realize that even such giants still teach us lessons in astronomy explained about cosmic growth and evolution. What makes TON 618 even more intriguing is the speed at which it grew, much faster than current models predict. It's like watching a tree grow in minutes, something that challenges our expectations about the universe explained. These extreme cases are vital for anyone interested in space education videos, because they show that mind-blowing science is not just theory, but observable reality. Every detail we learn from TON 618 helps us refine our models of galaxy formation, pushing us to reconsider our understanding of the universe's early stages. And as we study these extraordinary cases, we can't help but wonder, if TON 618 is this surprising, what other mysteries is the universe still hiding from us? Astronomers are using new instruments like the James Webb Space Telescope to study distant quasars, measuring mass, energy output, and surrounding matter. In addition to studying TON 618, astronomers are using powerful new tools, like the James Webb Space Telescope, to examine distant quasars in unprecedented detail. This new technology is pushing the boundaries of deep space exploration, allowing scientists to measure mass, energy, and surrounding matter in ways that were once unimaginable. The James Webb Space Telescope is helping us to answer questions that were previously in the realm of speculation, providing invaluable insights into the cosmic phenomena we've only begun to understand. By using cutting-edge technology, we are now closer than ever to understanding the true nature of these supermassive black holes. With each new discovery, we refine our understanding of the universe explained, pushing the boundaries of our knowledge. Astronomers are piecing together clues about how galaxies and black holes formed, and their observations are providing us with new tools to make sense of cosmic mysteries. This ongoing research is helping to rewrite the science we thought we knew, and it's incredible to witness the expansion of space discoveries that were previously unimaginable. The more we learn, the more we realize just how much of the universe remains unexplored and full of hidden wonders. And as we push forward with these breakthroughs, we must also consider what this new knowledge means for the future. What other phenomena will we uncover as technology advances? What mysteries of the cosmos are we on the verge of unlocking? Wormholes, or Einstein-Rosen bridges, are theoretical concepts that have fascinated scientists and curious minds for decades. Imagine folding a piece of paper and poking a hole from one point to another. This is how we could mathematically connect two distant points in space-time. This idea is not just science fiction. It comes directly from Einstein's equations and offers us a glimpse into cosmic phenomena that seem to defy our understanding. When we explore mind-blowing science in space education videos, it's impossible not to be amazed by the possibilities these shortcuts in space-time could unlock. Even though they remain theoretical, wormholes stimulate fascinating space storytelling about future exploration and discoveries. What's even more exciting is that these shortcuts could, in theory, reduce vast distances in the universe to almost instantaneous travel. It's like using a world map and cutting across continents, but on a galactic scale. Such phenomena challenge our common sense of universe explained, showing us that space and time can behave in surprising ways. And when we think of analogies, like an apple with a worm traveling from one side to the other, it becomes easier to imagine these concepts without getting lost in complex math. Space facts about wormholes show us that, while we can't visit one today, understanding their implications brings us closer to the frontier of science. Furthermore, studying wormholes gives us a unique perspective on the limits of physics and future engineering possibilities. Science has already proposed models that explore shortcuts and manipulations of space-time, even though they face huge technological challenges. Every theoretical experiment, every simulation in deep space exploration, teaches us cosmic mysteries that are as challenging as they are fascinating. And as we reflect on these ideas, the question naturally arises, if such shortcuts are possible, how would they interact with black holes or other extreme phenomena we've already observed? Despite their allure, wormholes face enormous practical limitations, especially the need for extreme gravity to keep their doors open. It's like trying to hold up a colossal bridge with human hands. The physics just don't cooperate. Studies in cosmic phenomena show that entering through a black hole is theoretically possible, but the exit is uncertain and possibly impossible. These challenges remind scientists that space discoveries and mind-blowing science don't always translate to immediate applications. Still, exploring these ideas brings us closer to understanding the universe explained at its deepest level. Another fascinating issue revolves around the second law of thermodynamics, which seems to resist the idea of white holes as the exit for wormholes. It's like nature saying, sure, you can dream, but there are rules. This scientific debate sparks fascinating space storytelling, showing that every theory must deal with real-world limitations. Even though these concepts might seem speculative, they offer space facts that clarify the relationship between energy, matter, and time in the universe. And these discussions stir curiosity. If there are potential violations of known laws, what other cosmic secrets remain hidden? Moreover, understanding these limitations offers perspective on how complex deep space exploration truly is. It's not just about traveling or observing, it's about comprehending extreme physical interactions that challenge our intuition. Each problem raised forces us to think creatively, fueling space education videos that promote the pursuit of cosmic mysteries. As we ponder these difficulties, our minds naturally turn to futuristic solutions that might overcome these obstacles. Even though wormholes remain theoretical, recent experiments have provided fascinating indirect evidence. In 2015, scientists created magnetic wormholes in a laboratory using superconductors, enabling them to observe measurable effects that once only existed in mathematical models. These experiments aren't space travel, but they're pushing the boundaries of what we understand about cosmic phenomena. Every new discovery in space education videos gets us closer to validating ideas that were once thought to be pure science fiction. It's incredible how abstract concepts of cosmic phenomena can now be tested and measured right here on Earth. What's even more exciting is the distinction between gravitational and magnetic wormholes. While gravitational ones remain in the theoretical realm, magnetic wormholes offer tangible, observable effects that demonstrate space phenomena we can interact with on a smaller scale. These experiments show how advancements in space discoveries and mind-blowing science can lead to practical applications that change our perception of the universe. And watching these tests in space education videos allows everyone to see science at work. Furthermore, these experiments remind us that science is all about trial, error, and creativity. By combining theory, analogies, and practical experiments, astronomers and physicists are turning cosmic mysteries into observable phenomena. Every breakthrough in space storytelling and astronomy explained helps us understand that even the most radical ideas can have real-world foundations. And as we dive deeper into these indirect experiments, it naturally raises the question, what technologies will we have in the future to make these theoretical concepts a reality? When we talk about futuristic alternatives, concepts like the Alcubierre drive make us dream of almost instant interstellar travel. This space-time warp would allow travel across vast distances without breaking the speed of light, something that sounds like it's straight out of science fiction, but it's based on solid mathematical principles. It's a great example of how mind-blowing science can transform universe explained into exciting possibilities. Every such proposal inspires us to think about deep space exploration in creative ways, combining theory and human ambition. As we dream of these solutions, we realize that the future of cosmic exploration depends on imagination and innovation. Other solutions derived from Einstein's equations explore shortcuts and manipulations of space-time that are still purely theoretical. While fascinating, these ideas face enormous technological challenges, placing space discoveries and cosmic phenomena into the category of concepts we can't yet touch. Yet, studying these ideas offers captivating space storytelling and sparks scientific curiosity, showing that every breakthrough begins as an impossible concept. It's like planting seeds in the soil of the impossible and watching what might grow with time and effort. These futuristic alternatives also remind us that science is constantly pushing boundaries. Even without immediate technology, understanding theories like the Alcubierre drive or other space-time manipulations lets us connect theory with practical applications in astronomy explained. Each reflection on limits and possibilities fuels the passion for space education videos, motivating knowledge seekers to continue questioning and learning. As we look toward these futuristic ideas, one inevitable question comes up: how far can humanity go if we manage to turn theory into reality? As we look toward these futuristic ideas, one inevitable question comes up: how far can humanity go if we manage to turn theory into reality? The universe is full of mysteries, and we've only scratched the surface. If you're fascinated by these mind-blowing possibilities, there's a lot more to explore. The search for answers doesn't stop here. Every new discovery opens the door to deeper questions, and the universe continues to challenge what we think we know. Stay curious, keep exploring, and remember that the greatest cosmic mysteries are often the ones we're only beginning to understand. Don't forget to subscribe and turn on the notifications so you never miss out on the latest space discoveries and deep space explorations. The journey through the cosmos is just beginning, and you won't want to miss a second of it.